Okay. All right, a final torque question, pretty common one, the ladder problems. All right, first thing we have to do is draw a free body diagram. So we'll do that here, labeling all of the forces. Well, let's see, there's the weight of the man. The weight of the man. There's the weight of the ladder itself. Call it ladder. And the floor is going to provide a normal force, the force normal from the floor. Also, the ladder doesn't slide out, so there's got to be some friction force this way. And then over here, this wall, this is frictionless wall. The problem says that this is a frictionless wall, but the wall will still push this way, so there'll be a normal force from the wall. There are 5 forces here. 5 forces. Now, if we go traditional route and go sum of the forces in the x direction equals ma, which is equal to 0 because it's in equilibrium. In the x direction, you get the force of friction to the right minus the force normal from the wall equals 0, or the force of friction, the ladder on the floor, is equal to the normal force from the wall on the ladder. But you don't know what anything is. 2 unknowns. 2 unknowns. 1 equation, 2 unknowns. That is a problem. But let's keep things going. Let's go sum the forces in the y direction. Ma sub y equals 0. It's in equilibrium. Sum of the forces in the y direction. We get the normal force of the floor. That's up minus the weight of the man minus the weight of the ladder equals 0. So here you're going to end up with the normal force from the floor is equal to the weight of the man plus the weight of the ladder. Now the man has a mass of 200 kilograms. So 200 kilograms, we'll use 10 meters per second squared for G. That's going to give you 2,000 newtons. The ladder itself is 5 kilograms times 10 meters per second squared. That's going to give you a weight of 50 newtons. So the normal force of the floor is equal to 2,000 newtons plus 50 newtons, or 2,500 newtons. So we can figure that one out. 2,000, I said 2,500. I should have said 2,050. 2,050 newtons. 2,000. In the y direction, it works. But we can't find all the forces because we have 2 unknowns. So it seems like we're stuck. Unless you go to sum of the torques. If you go to the sum of the torques, and we can look at these 5 forces, we'll call this force 1, this we'll call force 2, this we can call force 3, this could be force 4, and this could be force 5. So if you were to go sum of the torques equals 0 because it's in equilibrium, the sum of the torques is the torque of force 1 plus the torque of force 2 plus the torque of force 3, the torque from 4 and the torque of 5. All of these things. Pretty straightforward. All of that equals 0. Now here we have to define a pivot point. Remember, in general, torque is equal to the force times the radius times the sine of the angle. Only the perpendicular piece of the force causes it to twist. So for torque 1, well, actually, back up, make a pivot point. If we make this our pivot point, which definitely makes sense to make that the pivot point, make this the pivot point, then R for both of those forces is 0, and 2 of those forces will vanish. So we could say the torque of 1, let's see, torque of 1. So normal force of the floor times R, which is 0, times the sine of 90, whatever it's going to be, and it's going to go to 0. So that's the torque of 1 goes to 0. The torque of 2 is also going to be the force of friction times 0 times the sine of 37, but that's, who cares, because it's going to go to 0. So torque 1 and torque 2 go to 0. So we could say the sum of the torques is, if we make this the pivot point, it's going to be just torque 3 plus torque 4 plus torque 5, which is the force of the man. Now, the force of the man is 2,000 newtons. The distance is from the pivot point was 5 meters. And only the part of the force that is perpendicular to that. If that's 37, that angle there is 53. So it's the sine of 53. Right? Only the component, that angle is 37. It would be, we could say the cosine of 37 or the sine of 53. You have to do a little bit, right? If this angle is 37, then this angle there is 53. So here we want to say the sine of 53. It's only the perpendicular part. Plus, and the same thing holds true for the ladder. Same angles, but it's going to be different forces. 50 newtons times the distance of the ladder is 6 meters away, right? The ladder is 12 meters long, so the center of its mass is halfway, 6 meters. And this is also going to be the sine of 53, same angle. Now, these things are going to cause it to rotate clockwise, so I'll call that negative and negative. And then the normal force on the wall would produce sort of a counterclockwise rotation. So it's going to be the normal force from the wall times 12 meters. It's 12 meters away from our pivot point all the way at the end. And this time it's going to be, what angle are we going to deal with here? It's going to be the sine of 37. All right, so if you think about this line here, this angle in here is going to be 37 degrees. The perpendicular component of this force, or you can think of this being 53 out here. And it would be the cosine of that 53 or the sine of 37. I'm running out of space. Sine of 37 degrees. All of that equals 0. So basically you end up with, let's see, grab the calculator. Do the math. 2,000 times 5 is 10,000. 10,000 times the sine of 53. Is just about 8,000. Negative 8,000 newtons. Minus 50 times 6, 300, times the sine of 53, which is pretty much 0.8, 240. Plus the normal force on the wall, that's our unknown. Normal force from the wall times 12 meters times the sine of 37 standard time, which is 0.6. So 12 times 0.6, 7.2. So we get negative 8,240 newtons plus 7.2, the normal force from the wall. All of that equals 0. Or you can bring this to the other side. 8,240 newtons equals 7.2 force normal of the wall. 8,240 divided by 7.2 is the normal force on the wall equals 1,144 newtons. Now, big deal. We've got that. That's nice to get that. Because now we already had the forces in the y. Over here, now we know the normal force in the wall. That's got to be the friction force. They have to equate. We had all the vertical forces from some of the forces. Now we've gotten the friction force. So the normal force on the wall equals the force of friction. So 1,144 newtons is also the force of friction. And that's all of them. We got it. Well done.